So, discrete and continuous random variables. This is going to be section 6.1 or 7.1, depending on which book you're in. Okay? Flamingo book, blue book. You guys, like the Flamingo book does a really good job of showing like formulas and stuff. Like I think their notes are a little bit better, but I think the problems, the outlining and the problems in the blue book do a little bit better. Okay, so a variable. So we're going to talk about different things. So a variable is a quantity whose value changes. Duh, right? Like we know this, right? It changes. A discrete variable is a variable whose value is obtained by counting. So I really always enjoy when I do these notes, seeing what I counted and what I write on my notes because it changes from year to year. So what are things that we count? Basically, I have number of students present. That's something I can count. Okay. Number of cookies eaten. Now, it is not, you don't ever say I ate 5.5 cookies. No. Okay, so it's cookies. How many cookies did you eat? Okay. Apparently last year, I don't think this was last year, because if this is chapter, is probably on the probability test, the number of F's on the probability test. That's kind of, apparently that's what I wrote. What's something else that you count? Count. Miles, because miles we're going to actually measure. So that's a measurement, yes. I was thinking the same thing too, but it's a measurement because we can 0.25 miles, where cookies, you're going to eat a whole cookie. You would never eat it. Yeah.
Number of votes for a public office.
What?
Number of votes for a public office.
Yep. It's funny that you said miles because that's the one that I have. Number of F's, number of M&Ms in a bag. So you guys, it's never, remember, you're going to count. So if you have half pieces, they go out because they're not M&Ms, right? I mean, they are M&Ms and they're still delicious, but anyways, so that's a discrete that's a discrete variable, okay? Not random, that's a discrete variable. And that is a variable whose value is obtained by counting, okay? And so you guys, you can almost see this as a question, right? Can you see, like, knowing which one is a discrete variable, which one is a continuous? So a continuous variable, and now again, you guys, the word random is not in there yet. We're going to get to that. So a continuous variable is a variable whose variable is, okay, apparently, I can't read, whose value is obtained by measuring. So Amy already gave us one, and that's like distance to school or miles driven. Now our cars no longer, they don't use a decimal, but they used to. Miles driven, that would be considered like distance to school. You guys, height of a student. The one that everyone hates. I always tell the eye doctor that she's my favorite doctor because she's the only one that doesn't weigh me when I go to the doctor. Wow, you guys are not on fire today. And,
What about time?
yep, time. How long it takes you to run a mile, yes. Time. This is funny. I don't know why I did this, but Florida's temperature, or just temperature in general. Okay. You guys, there's going to be a question just on what random variable is. It was kind of like the question on probability that was on your quiz that you took right before break. And a lot of people missed it because you guys, when you think about a random phenomenon, in the long run, it's that. In the long run, probability or chance is predictable. In the short run, it's not. And a lot of you missed that question. So I want to draw your attention because random variable. A random variable is a variable whose value is numerical outcome of a random phenomenon. Okay, so we're going back to a little bit of probability. A random variable is denoted by a capital letter. We usually use X, okay? The probability distribution of a random variable X tells us what the possible outcomes, possible values of X are and how probabilities are assigned to those values. Actually, you guys, what's funny is one of these is we've already done a probability distribution. You've seen it. We just never called it a probability distribution. Now they're going to ask you to make one. And actually, there was a probability distribution question on the probability worksheet from yesterday, the multiple choice, that you kind of had to do a distribution for. And a random variable can be discrete or continuous. So we're going to do a discrete one, and then we're going to talk about continuous. And the problems that we're going to do out of the blue book today are going to be continuous. But it's, again, you guys, it's going back to that z-score. Okay, so a discrete random variable. Now notice the word random is in there. Okay, so a discrete random variable means it's countable and it's going to have a probability. X has a countable number of possible values. Let X be the sum of two dice. So then the probability distribution is as follows. So notice my X is, these are all the possible outcomes. So I can get a 2, I can get a 3, I can roll a 4, a 5, a 6, a 7, 8, a 9, a 10, 11, and 12. Okay? Have you guys ever done the distribution of the dice roll before? Okay. So. Okay, so, let's see. So you can roll 1, 1, right? Well, if you roll 1 or 1, the sum is 2. If you roll a 1 and a 2, the sum is, wow, you guys, wow. 3 and 1? 4 and 1? 5 and 1? 6 and 1? 2 and 1? 2 and 2? 2 and 3? 2 and 4? So you guys understand now? You don't have to draw this. You know, you can, but this is whenever they ask you about a distribution of rolling a dice or the sums of the sum, this is the chart that they're talking about, okay? The reason I bring that up is because those are what the probability of X is. And we're going to leave them as fractions. You can change them, We probably will end up changing them to decimals, but for the chart, usually in the chart, you'll see fractions. You'll see decimals as well. Okay, so now what we're going to do is we're going to fill out this chart. So, what is the probability of getting a sum of 2? There's 36 outcomes. So to get the sum of 2, it would be 1 out of 36, because there's only one way to get a 2. To get a 3, there was 2 ways out of 36. To get a 4, there was 3 ways. To get a 5, there was 4. To get a 6, there is 5. To get a 7, there are 6 ways. And now it's going to go back down. 8, there was 5. 9, there are 4. 10, there are 3. 11, there are 2. And 12, there is 1. So that's our distribution. That's our probability distribution. So if they say they want a probability distribution, it's a chart just like this. Probably, I always use. It's funny because once I teach this section, and I learned it, I do a probability distribution a lot. Like whenever time you draw a chart, and you guys think about the typo blood or the M&M question on the quiz, that was a probability distribution chart. Okay, so now what we're going to do is we're going to do a probability histogram. That's exactly what it sounds like, you guys. You're going to put your probabilities on one side, and you're going to put your outcomes on the end. So the probability and then your outcomes. So 2, 3, 4, 5, 6, 7, 8, 9, 10, wow, 11, 12. I did not do this one as well as I did the other one. And then your probabilities are 0.00, 0.5, 0.10, 0.15, and then 0.2. Well, again, I do not have any spatial sense apparently. Number sense maybe, not spatial sense. And then you draw these are your outcomes. And so what's 1 divided by 36? Is 0.3, right? So it kind of goes in the middle. So when you're done, this is what it should look like. Okay? You should have a symmetric probability. You guys, remember, because they say a histogram, your bars have to touch. If it looks like a bar graph, then it's a bar graph. And remember, bar graphs only work for categorical data, okay? Okay. Need that. There. Okay. You guys ready for the back of this? Good. You know, you can't use the back for this. We'll use the back for this one. Okay. So you guys, basically continuous random variables are, remember when we did z-scores, we did normal curves? That is what we're doing. We're doing normal curves again. Okay? Now the biggest thing is that this sentence right here. The probability continuous random variable that exactly equals the number is 0. So if I tell you something is a continuous random variable and I ask you what the probability of it equaling 2, right? You would write 0 for a continuous random variable. I thought I had a better page. I probably didn't. So basically, if I tell you something is a continuous random variable, those are the same, no matter what. Those both have the same probability. If it's a continuous random variable, these will have the same probability. If it's a discrete random variable, they would be different. But it's a continuous random variable, these will both be the same because the probability of x equaling 2 at a continuous random variable equals 0, always. If I told you the probability of x equaling 3 and it's a continuous random variable, it's going to be 0. So again, you guys, I just wanted to show you, it doesn't matter what number is there. If I ask you what's the probability of x being greater than 5 or x is less than 5, it doesn't matter. These two, doesn't matter about the equal sign, these two will always have the same probability. But if I ask you, hey, this is a continuous random variable, what is the probability of the x equaling a number? You would say 0. And they will get you on this, and I guarantee you it will be a question because they want you to know that. Okay? So, that's the end of the notes. Boom, right? So now what we're going to do is we're going to move on to some problems because those are more exciting than you guys listen to me drone on and on and on.